Okay, welcome to this video. So we're going to be solving equations. Again, these are the square root equations, and we could actually, excuse me, do any root, but we are going to talk about these square roots today on there. So we're going to go ahead and get started. I wanted to review just a couple of things that is kind of the background of why this works. Again, our rules of exponents that we've been working on, one is when we do a power to a power, remember the rule is to multiply. And so when I take 2 times 1/2, that is 2 over 2 or 1, or you can think of canceling it. And remember, these two are reciprocals of each other, and anything times its reciprocal is always equal to 1. That's actually the definition of why it is a reciprocal, is because when you multiply the two, you get 1. So it doesn't matter whether it is squared and then we take the square root of it, which is 1/2, or whether it is already the square root and we square it. Those are still the same operation that's taking place. Also remember, when we do write x to the 1/2, that is the same as the square root of. And so we could actually write this problem in two different ways, because number one could just as easily be written as x to the 1/2 equals 10. That's actually our next video, is when it's written in the fraction form on there. So today we're going to write it in radical form, and then in the next one we write it with the fraction as the exponent. Okay, so we're going to go ahead and just jump in and get started on these. So these are off of your worksheet, so definitely you want to write these down. Don't hesitate at the end of each one to pause it and actually write the work down. So what my suggestion would be for you, okay, is to watch it first, listen to me do it, and then you just go back in and copy the work down. So I wouldn't try to copy the work while I'm actually doing it. Okay, so let's go ahead and get started then. So since it is, again, the square root, the opposite operation would be to square. So what I do to one side, I do to the other. And so I'm going to square both sides. That means that the square and the square root cancel, so that's generally how we write that. And this would be x equals 10 squared, or 100. Okay? Now, one of the other things that we need to do is to always check it. So the question is the square root of 100 equal to 10? And yes, it is. So it checks. The reason we do this is because these type of problems in which we have radicals or rational exponents have what we call an extraneous root, okay? Extraneous root. And what that means is that it is possible that the answer you get won't work in the problem. And so you need to check it back and make sure it works. So what I mean by that is sometimes the answer you get when you put it back under the radical will give an imaginary number. And when we're solving equations, we do only want the real solutions, not the imaginary ones. So even though we've talked about imaginaries and we've learned those, we don't want any of those kind of answers of these problems. So again, check your answer. So number 3. So again, this is all by itself. Okay, so sometimes what we need to do is highlight the radical piece of it. So as you notice here, the radical was by itself, the radical's there's nothing else with it, and so we can just square both sides. The key is, again, guys, the radical must be by itself. Okay, radical must be, be by itself. Okay, so that is a key that we're working on here. So we squared both sides. Again, the square and the square root cancel. I'm going to get x minus 4 equals 9. We're going to add 4 to both sides. X equals 13. Okay, now again, don't hesitate to check that, because what I want to know is 13 minus 4 equal to 3. Well, that would be the square root of 9, and that is 3. So that does check. Okay, I should have left more room. I would suggest for you to leave more room. Leave room to the side to do your check. Okay, again, on this one, our radical is by itself. So I can go ahead and just square both sides. So the square and the square root cancel. I'm just left with what's under the radical, which is 4b. Divide both sides by 4, and b equals 1. Okay? And I'm going to just quickly check myself. So 4 times 1 is the square root of 4, which is 2, which is what I was trying to get it to be. Okay. Our next one, I'm going to move this out of the way. So again, here is our radical piece. And I just said the radical must be by itself. Okay? So we're going to go ahead and add the 8 first. So I'm going to get my radical by itself. Here it is, 5a minus 5. Okay, so my square root is by itself, and now I add, and again, my next step would then be to square both sides. So my square and my square root cancel. I've got 5a minus 5 equals 25. Go ahead and add your 5 over. Now, I'm not going to spend a lot of time on the actual solving of it because by now you should be able to solve. If you can't, that's another concern that we have. Okay, now I'm going to check myself real quick. So a negative 8, negative 8 plus square root of 5 times 6 minus 5. And I want to know, is that a negative 3? Okay, so a negative 8 plus, and that would be 30 minus 5. Negative 8 plus the square root of 25. Negative 8 plus 5. That is a negative 3, so that checks. Okay, so this is my check. Okay, next one. Okay, so the square root is by itself. And guys, I don't think it hurts at all. I almost was going to require you to get a highlighter and highlight that piece of it. If you guys have too many problems with this, I probably will. But what I mean is you should highlight that, just that radical piece of it. Remember, you can't take the square of both sides until you have that by itself. So 1 equals, again, those are going to cancel, x minus 5. Then we're just going to go ahead and solve it. So x is 6. Again, we're going to do a quick check because 6 minus 5 is square root of 1, which is 1, and that's what I want it to be. Okay? Okay, so how's it going so far? Are these making sense? Are they too hard, too easy? And at any point, guys, you have questions, please don't hesitate to ask on that. So if you're working through this or watching the video, even if we're in class, because some of you guys are going to be watching this after your test, don't hesitate to come up and ask if you don't understand something. So again, highlight that. I'm going to go ahead and move the 10 over first, because again, I want my radical piece, my square root, to be by itself. Okay, and that's 3. Now it is, so I can square both sides. So 10m minus 1 equals 9. Solve. 10m equals 10. Guys, again, don't skimp on my work. Okay, and we're going to check it. So I'm going to come over here and do my check real quick. So 10 plus the square root of 10 times 1 minus 1. That should give me 13. And 10 times 1 is 10. 10 minus 1 is 9. And the square root of 9 is 3, which is 13, which is what I want it to be. So far, we have no extraneous roots. Okay, the next one we're going to do real quick, let me get that problem, is number 17. Oops. I just moved it down. There we go. Okay, and now when you look at this one, hopefully you notice something different. You actually have a square root in this case on both sides, but they are by themselves, which is a good thing. So we can go ahead and just square both sides. What's going to happen in this case is The square and square root will cancel. I've got left with a 3n. Also, your square and your square root will cancel on this side, and you get 4n minus 1. Okay? Now, you should be able to solve your equations from there. So let's move our n over. I get a negative n equals a negative 1. Remember, we divide by negative 1, so n is 1. Okay? Now, let's check it and make sure it does work. And of all the ones that won't work, typically it is the ones that look like this. If they're not going to work, it is the one where you have the radicals on both sides. So this is the square root of 3. This is the square root of 4 minus 1, which is the square root of 3. So those are going to check in both cases. So this is good. Okay? So just to add one extra thing to it is, again, what do you think we would do if it was the cube root? Let me give you a smaller number. If it was the cube root equals 2. So again, cube root is x to the 1/3. So hopefully that makes sense that we would cube both sides, right? So I would come cube both sides. So cube and cube root would cancel. X would be 8. If it was a fourth root, maybe it was x minus 1 equals 2. Again, fourth root, so I would need to take it to the fourth, right? Fourth root and fourth cancel. I'm going to get x minus 1 equals whatever 2 to the fourth would be. What is that? 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, move the 1 over. So we can extend this lesson to actually any root, okay? Whether it's third root, fourth root, fifth root, or so forth, okay? So again, that's going to hopefully lead us into our next lessons. So you are finishing this, all of the problems on this worksheet as your assignment. Again, if you have any questions, don't hesitate to ask.